Everyone, we are getting ready to begin our next presentation here in the Philips booth. We have a great one for you, all about artificial intelligence with Dr. Elliot Siegel, who is an expert and pioneer in this field. So we're very excited to have Dr. Siegel with us, and we are going to get underway in just a few moments. So I have just enough time to invite you guys to join us and come on in. I need to switch this over here to get everything set. There we go. And then I think we should have a little video that'll start us off here. Is that right? Let you guys handle that? Yeah, right. Oh, there we go. That's the one. Oh, great. I guess we'll go right into it. Okay. Well, that's okay. I'll just do a little housekeeping before we invite Dr. Siegel up. So I have space available. First of all, we'd love to have you join us. I know everybody's standing there, but I promise you this will be a great session, and we'd like to give Dr. Siegel a good audience here before we start. So people get shy once the presentation is underway. They don't want to come in, but I guarantee you, you're not going to want to go anywhere, and you're going to want to be comfortable. So please grab a spot. I'll fill up 2 more spots here, and then we can start officially. And while I'm waiting to get those 2 magic spots filled, we have some housekeeping issues to tell you about. I've got the program for the week. We have a lot of fantastic offerings here. In addition to this presentation from not only some of the experts in the field and also different clients and customers but also from some of our top leadership here at Philips. We've had our CEO and our Chief Technology Officer in. So if you want to see the topics, it's always something different, and it's always at the top of the hour. So I see my entreaty to ask 2 people to have a seat did not help at all, but I'm going to try one more time. Please have a seat. I would love to have a couple spots filled up. I'll admit we have a camera here, so we'd like to do it. But if you're going to be standing one way or the other, might as well be comfortable. And then I think Dr. Siegel feels more comfortable when he's surrounded too, right? There's more of a sense of intimacy than if we have this barrier. So 2 more spots. Welcome, sir. Thank you for sitting. Thank you for joining us. That's really nice to see you, Raymond. Anyone else? We'd love to have you join us. All it takes is one interested soul. Thank you, sir. And, you know, the good news is from sitting down is if you get bored, you can walk away from this position just as easily as anywhere else. But that will not happen today, I promise, because we have a great one for you here in the forum. And we're going to go ahead and get started with that right now. So let me welcome you officially, and we're glad to have you here at the Philips Connected Health Forum. I'm Paul Traynor. I'm your host this week. Between now and tomorrow, we will have a whole range of exciting sessions and outstanding speakers with topics ranging from population health and care coordination and personal health to advanced analytics and clinical informatics. All happen right here in the forum at the top of every hour. So once again, you can grab a schedule right there before you go for topics and times. Right now, we're very honored to welcome Dr. Elliot Siegel, Professor of Diagnostic Radiology for the University of Maryland Medical Center and Adjunct Professor of Computer Science. Among his many accomplishments, Dr. Siegel created the world's first, radiology department? The Filmless Radiology Department, that's right. He's brought a lot of these innovations to healthcare, and he's a researcher in machine learning and digital imaging. In his talk, Artificial Intelligence, Hype, Myth, Reality, and how it will revolutionize healthcare, I think Dr. Siegel will cover how machine learning is being used for driverless cars, speech recognition, and human vision, and also how innovative AI will transform the way medicine is practiced in the next 20 years. We are very excited to have him here with us at Philips, so please help me welcome Dr. Siegel.
Thanks. Thanks for the clicker. Hi, thank you all for coming to this session. I don't think there's ever been any time during my career in medicine where there's been so much excitement and so much fear at the same time. That's a really interesting combination. And so what I'd like to talk about is the hype, myth, and reality of artificial intelligence. I've been working with Philips for the last few years and had the opportunity to tour around a little bit, and I'm really impressed with how many of the things that we've talked about with regard to machine intelligence have already been incorporated, and the roadmap also. So this is one of many emails that I get every 2 or 3 weeks, and this is one from a radiology resident in Portugal. And she writes that she decided to go into radiology for her interest in theoretical problems, informatics, and a variety and a broad range of medical knowledge. But now she's really scared because she's been told that radiology and radiologists and doctors in general are going to be replaced by computers. Here's another one from Andrea Romano, who's an Italian second-year resident. And so whether I'm talking with the residents or medical students around the world in email, or our own medical students at the University of Maryland, people are being told that they're going to be replaced. How many of you think you're not going to be replaced by a computer in the next 10, 20, 30 years or so? Yeah, so let's talk a little bit about that. If you read The Economist or any magazine, you're reading essentially about artificial intelligence and here the march of the machines. And The Economist talks about the fourth industrial revolution based on cyber-physical systems. If you look at this quote where it says, the substitution of machinery for machine labor may render the population redundant. The discovery of this mighty power has come before we knew how to employ it rightly. That could apply to today, but it also applies, and it was actually from a debate in the early 1800s with the Industrial Revolution. Andrew Nigg, who's a renowned expert in machine learning, has essentially said a highly trained and specialized radiologist may now be in greater danger of being replaced by a machine than his own executive assistant. Emmanuel Ezekiel, who you all probably know as the architect of Obamacare, essentially has made the statement and has written in the New England Journal of Medicine that essentially the biggest threat to radiology is artificial intelligence and also secondarily medicine. He suggests that we may be replaced sometime in the next 4 or 5 years. So how true is that? If you take a look at Jeff Hinton, one of the renowned experts from University of Toronto and now with Google, he essentially tweeted, we should now stop training radiologists right now. In 5 years, deep learning will have better performance. So I believe that this is all absolute nonsense. And what I'd like to do is explain why, and why you should be excited and why you shouldn't be fearful about AI. Oh, and here's one final quote from a well-known, well-funded CEO of a startup company in the medical imaging space, essentially that said that he wants to get rid of the wasted protoplasm sitting in front of the workstation that represents the radiologist with something more consistent. He predicted he was going to do that actually a couple years ago within the next few months, and he's no longer CEO of that particular startup. This isn't the first time we've been told that we were going to be replaced by computers. This is an actual ad in 1904 where they came out with a vibratory doctor, which was going to replace physicians in general. And so, you know, this is just a renaissance of being replaced by computers. So let's talk a little bit. What is AI actually, and what is machine learning? Because I think there's a lot of misconceptions about that. Deep learning actually falls inside of machine learning, which falls inside of artificial intelligence. And artificial intelligence is really an umbrella term for a different variety of applications and techniques. John McCarthy is credited with first coming up with the term artificial intelligence in 1956, and he complained that as soon as it works, nobody calls it artificial intelligence anymore. So here's a great example. We're in the year 2017. Does anybody know the square root of 2017? Does anybody know whether it's a prime number or not? Is it divisible by 37? Well, you just pull out your calculator, right? You can buy a calculator that answers that question for $1. 100 years ago, this would have been considered artificial intelligence. Is it artificial intelligence, or what is artificial intelligence? It would really take a long time for a human being to come up with the square root of 2017. And by the way, 2017 is a prime number. Artificial intelligence as it exists today can be thought of as narrow artificial intelligence or weak artificial intelligence. Speech recognition, translation, self-driving cars, Siri, Alexa, Cortana, all look miraculous, but they're examples of weak or narrow artificial intelligence. And so what we're really looking for, if we're going to replace the jobs that you all do, or the job that I do, essentially with strong AI, or what's called general AI. We're nowhere near general AI at this point, and that's really important to underscore. What does general AI entail? Well, Linda Gottfredson essentially says it entails the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. Those are all things that you all do, that there's no computer at this point that really does all these different things, and we're nowhere close, and we don't know when it's going to come. When will artificial general intelligence arrive that will potentially have the potential to replace us? Well, in a conference that specializes in artificial intelligence, 42% of people predicted by the year 2030, 25% by the year 2050, and 2% said never. 10% said after the year 2010. So it looks like even amongst these experts, we have a little bit of time. Machine learning is something you hear all the time, and you can't walk 10 feet in this conference without hearing machine learning or artificial intelligence, but it doesn't necessarily mean that the system learns as time goes on. Machine learning is really an advanced statistical technique that essentially is an extension of what we've been doing with statistics and analytics. There's nothing intelligent, there's nothing that implies that it has to learn. It uses a different approach to analyzing data, and we'll talk about that in just a minute. And so fundamentally, machine learning is about recognizing trends from data and essentially putting them into categories. When someone says machine learning, they're not talking about any one technique, they're talking about one of thousands of different techniques. And machine learning focuses on prediction, whereas data mining focuses on discovery of previously unknown properties. Machine learning and statistics are really closely related. So if somebody says, oh no, we're not going to do statistics, we're going to do machine learning, they really are essentially along a continuum that can be referred to as statistical learning. So let's talk about an example. If you take this where we're looking at lung nodules, and if you look at the left lower quadrant, small lung nodules that are smooth tend to be benign. They're not malignant. But it turns out that it's not quite that easy, that really large lung nodules that are spiculated may end up also being benign as well. And so can you create a regression formula, a line that separates between the benign and malignant nodules based on just those two variables? Well, with a typical regression formula, you really can't. And the question is, can you draw a series of lines that separate out the benign from the malignant lesions using something that is better than a traditional statistical technique? Here we have beauty. And in this hypothetical example, we define it as, is this pig beautiful or not beautiful? Well, let's say we define that as a function of eye distance to mouth ratio and eye distance to nose ratio. And let's say we get a bunch of people judging pigs. And let's say it turns out that all the pigs that fall within a certain range are beautiful, and outside that range they're blue. Can you draw a line that separates beautiful pigs from not beautiful pigs? No. Well, it turns out that it actually makes a heart shape. And if we used a machine learning technique, unlike a statistical technique, it could come up with what turns out to be a fairly simple formula that essentially draws a heart shape. In this case, if we applied machine learning, you could get a 100% discrimination between beautiful pigs and not beautiful pigs. And so what machine learning does essentially is it finds what are the variables using linear algebra that most closely correlate with the data that you have. And it tries to make it as simple as possible. So we've been doing machine learning for 30, 40, 50 years. Why the hype? Why is everybody scared about losing their jobs now and not 30 years ago? Well, what's happened is computer vision has progressed substantially, and Stanford did something called the ImageNet Large-Scale Visual Recognition Competition. And what ended up happening was they found that they were able to, starting in 2012, they were able to go from a 25% error rate to a 10% to a 5% down to a 2 or 3% error rate. And because of that, they've come to the conclusion that they've solved the human vision problem, and they've solved the problem of being able to take an image and be able to interpret it. The problem is you can't interpret telling what is a dog versus a cat or a table versus a chair with radiology. It's a completely different challenge. And so I think because of the success with ImageNet, people have made those predictions about replacing radiologists, physicians, administrators, technologists with computers. We still don't know how to test humans to know whether or not they're competent doctors or not, much less testing computers. And if we had a robot that came from 300 years in the future that actually was better than any doctor or any radiologist, how would we determine it? How long would it take the FDA to clear this robot from the future that actually was better than a radiologist? It might take it 30 years to actually clear something, even if we had something that worked today. Where are the databases? How would you essentially correlate it? And so here in the Harvard Business Review, just in November of 2016, they made the distinction between ability to make predictions and judgment. You all are good at judgment and pretty good at predictions. Machine learning is good at predictions, lousy at judgment. And that makes a really big difference. One of the hardest tasks is human vision. And in fact, your 5 or 6 or 7-year-old kid can tell you what's wrong with this picture in just a few seconds. No one's ever created a computer program that can beat a 5 or 6-year-old kid at this Highlights magazine task. And in Scientific American in 2011, they suggested that this may be a better test for consciousness than the Turing test that was proposed in the 1950s, suggesting that if you could fool somebody into thinking that a computer was a person, then that would be the arrival of consciousness. This actually represents a much harder task. And imaging may be one of the ultimate challenges for AI software. So let's talk about some of the challenges with machine learning that we have today that are important for you to know and remember. One challenge is, it's like the joke about standards. Isn't it wonderful about standards nowadays? There's so many to choose from. Well, there's like an irony there, and it's the same with machine learning. There are thousands of techniques to choose from. Can you assume that advances in object recognition really can be applied to medicine or diagnostic imaging? Just because you can identify a chair, can you tell whether it's a pretty chair, whether it's a broken chair, whether it's a comfortable chair, whether it's a dirty or clean chair? That's a major issue. Another issue with machine learning is it's a black box. You can train a machine learning algorithm, but you don't know why it is that it's doing what it's doing. And so how you get that past a regulatory analysis is really going to be a challenge, and how you know it's doing what it's doing is really important too. I have a challenge that I issued to the entire world for the last few years about finding the adrenal glands on a CT scan. I still haven't found anybody that can find the adrenal glands on a CT scan better than a 5th grader. If anyone has an algorithm that can do that, I will wash your car anywhere in the world. And so if the computer can't even find the adrenal gland, how's it going to diagnose it and replace me in the next 3 or 4 years? You know, I think that's unlikely. No general purpose learning systems exist like we train our residents, and our eyes and brains have evolved over many years. So what are challenges? Which machine learning algorithm do you choose from? How do you evaluate different algorithms? How many cases do you need to test a machine algorithm? Nobody has any idea of the power statistic for training machine learning. How about computational times? People tell me that they're using graphics processors to speed up the computational time, and it's great, but does that mean it gets the wrong answer in a microsecond instead of getting the wrong answer in a second? And so it's not just the speed up that we're looking for. What are some applications in medical imaging? Well, there are thousands of applications. How many do I have at my desktop? Essentially 0, maybe with the exception of mammography CAD, and I'd like to see that change. And so how can I bring all of those things and bind them together in something that I as a physician can actually use in machine learning? What are some major advances in non-machine learning? Well, there's some really exciting advances outside of medicine. This one's one of my favorite, where what the Google DeepMind team was able to do is, you probably recognize that some of you may recognize this as an Atari controller that plays Breakout and Pac-Man and all sorts of video games, 70 or more Atari video games. What they did is they put the computer in front of the TV and watched the score and nothing else. And so they didn't train it on how to play all of these video games. They just trained it to watch the score and see what happens when you move the paddle around. And so here's DeepMind learning how to play the game that you have all probably played at one point or another, Breakout. It starts out where it's impossibly bad. You know, the ball just keeps dropping. It doesn't even know where to put the paddle. And then after a while, it starts learning that if the paddle is made to line up with the ball, that it'll actually get a higher score. So here what you have now is after 2 hours, it starts playing like an expert. So it's like a kung fu master at this point at actually taking the paddle and hitting the ball. The next thing that happens is kind of magical right after that. What it does is something that a human would do, but maybe you wouldn't expect the computer to learn, and that is it learns this really cool trick. Whereas if you break through the wall and get the ball to the back of the wall, the ball starts bouncing around in the back and knocking out the pieces in the back. So after 4 hours of just playing the video game, and it could be faster, of course, than that if you made it computationally faster, it learns to break a hole in the wall and get to the back of the wall. No algorithm, no training, except just to tell it to run an optimization algorithm to optimize the score, with no instruction on how to play any of these games. That's kind of scary as far as the idea of eventually replacing a radiologist or physician. You're probably familiar with the Go, which was predicted that it's so much more complex than chess. You see the number in the fourth bullet point of how many combinations. That's more than the number of atoms in the universe. And so the Korean folks thought it wasn't even going to be a challenge. They thought it was going to be a joke playing against Go. What ended up happening was they ended up playing and actually being defeated soundly 10 or 15 years earlier than most pundits thought that Go was actually going to be defeated. This is a picture of me in my self-auto-driving car driving over one of the scariest bridges in the U.S., the Chesapeake Bay Bridge. That's not the car careening back and forth, that's the camera moving back and forth. But would you trust an algorithm to drive you across a bridge at 45 stories up in the air? If you did, how would you debug software that's as complex as that? And how do you know whether it's doing what it's supposed to? If it tells you it's 3 times safer than driving a regular car, not on autopilot, but every once in a while it makes a really bad boo-boo and drives you off the bridge, would you trust the car to do auto drive even if it's 3 times safer? And how can we trust it in medicine to essentially do the same thing? And so what people say is, could AI ever be creative? And when you poll patients, patients don't want you to be the smartest doctor in your medical school class. They don't care. What they want is for you to be confident, empathetic, humane, personal, forthright, respectful, and thorough. Could you ever actually train a computer to be empathetic? Could you train a computer to essentially watch?
Ellie.
And so here's the answer to that question.
I was created to talk to people in a safe and secure environment. I'm not a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself.
So, watching this computer program in action, there's no doubt it's a lot more empathetic than a lot of doctors that I know and work with. And so, I'm not sure that even empathy is something that we can simulate. So why won't we be replaced anytime soon, physicians or radiologists? There's tens of thousands of algorithms that have been developed in the last 30 years. I hardly have access to any of those, as I'm at a workstation nowadays, number one. Number two, the only application I have is mammography CAD. Only 2% of my colleagues say they regularly change their diagnosis based on mammography CAD, which has been around for 20 years, and 20 years ago was said to be as good as mammography experts. Well, 20 years later, we don't see that, and so where will we be in 5, 10, or 20 years from now? And so we're going to need to rethink how we essentially deploy some of these algorithms. And assuming that you had all of these available, as I mentioned, it might take 30 years for the FDA essentially to clear it. So I think it's really, really important to understand some of these major challenges. How long would it take to complete the testing of an algorithm that actually was purported to replace a physician or a radiologist? How about medical legal issues? Who's going to take responsibility medical legally if you had a system that replaced a physician? How long would it take people to buy these, and what would they cost essentially? And it's much more likely that we'll be making incremental changes, and the physicians will be working with the computers. And so there's incredibly exciting potential in machine learning. You're seeing analytics for readmission, risk assessment, population analysis, personalized medicine. And in fact, we've done some work where we've downloaded the National Lung Cancer Screening Test, where we're able to personalize a specific prediction about benign versus malignant using lung nodule database and also using a huge database of 155,000 patients where we followed them for cancer for 15 years. Each of these studies cost NIH about $250 million. Repurposing them so that we can use them with machine learning to be able to tailor a diagnosis to a specific patient is going to revolutionize the way we do personalized medicine. So in the next few years, I'm optimistic that machine learning is going to have a major impact on diagnosis. I just expect there will be more physicians, more radiologists, and more of us around partnering with computers, as we've seen here at Philips. And so I think the main things I'd like to see from a HIMSS perspective, if any of you are developers, is one, I need a mechanism for delivering these algorithms in an ecosystem to me. There's tens of thousands of algorithms. I can't get them, even though I see the best and the brightest at some of the research conferences. How can I get access to those rather than just those developed by a specific vendor? How do I index and tag the best algorithms that are out there? And can I create an ensemble? Can I have multiple algorithms that do the same thing, that vote, and all cooperate together to make them even smarter? Those are the things I want. So I'm here to tell all the worthless protoplasm that represents me and you and everybody else, radiologists, doctors, and everyone, and the rest of you, that you can continue to ingest food, reproduce, create waste products without fear of being replaced by computers, at least in medicine and radiology anytime soon. So my recommendations to the residents that write me every 2 or 3 weeks, or medical students, finish medical school, finish your residency. There's lots of work to do, lots of low-hanging fruit in machine learning. It's really exciting where things are going. Humans have been around, if you consider Earth time as a 24-hour clock. Humans have only been around for 1 minute and 17 seconds. Computers have been around for close to a millisecond in that time. What's going to happen in the next millisecond? Nobody knows. So thank you all very much. I really appreciate you coming and attending. Thanks. Any questions, comments? Comments? Yes.
Yeah, so I love the idea of doctors, getting into the area of computer science, and it is just phenomenal.
I think it's important that doctors understand what you guys are doing in computer science and machine learning, and that the folks who are developing the algorithms understand medicine. This is a great forum for that.
So I hope more and more doctors, get involved, with companies like Philips or IBM or whatever the case may be.
Yes.
I think that would really help advance, what you just suggested.
Thanks. And I think it would allow us to be able to constructively work together. There's an incredible amount of fear, and I think a lot of people are resisting change in technology because of that fear. And so I think getting rid of the hype and explaining what these systems really do and what they mean are really important. So thanks for the comment. Really appreciate it.
So are they doing anything? Are the med schools kind of promoting, the idea
So at our medical school at University of Maryland, we have a boot camp, and the boot camp used to be how to use your microscope and stethoscope. The boot camp now is introduction to computers and computer systems and how we can use it as a tool. So we're changing, and it's happening really slowly. Nothing changes slower than healthcare, despite what you see at the meeting. And so we're hoping to try and change that a little bit.
Thank you very much.
Thanks. Any other comments, questions? Yeah.
Hi, I'm from DeepMind. Thanks for the plug.
Awesome.
My question really is not a question, it's kind of a statement, which is that AI is increasing exponentially in terms of progress. And a lot of the things you said about basic machine learning probably were true 2 years ago, maybe not so true now.
Do you think AI has been progressing for the last 30 years exponentially? Or
No.
So it's just been linear and all of a sudden there's some magic that's changed in the last couple of years?
I think what's changed is compute power is able to ingest data. There is more data to ingest. But fundamentally, I think a lot of the clever people working in machine learning are coming up with new techniques, not just the basic things you've highlighted here. And that is leading to things like the AlphaGo program and other things. My view is that machine learning will assist radiologists. And
yes, mine too.
It will help them do their jobs in terms of treating patients, not spend hours looking at scans trying to figure out what the solution is. Yeah, but I just wondered why you were sort of so negative about some of the machine learning elements at the start.
The irony is my research area is AI and computer applications and machine learning. So I've been the biggest proponent of the technology, review papers on this and have for the last many years. So I don't want to appear as negative. I just want to try and counter some of the hype. And I think there's lots of hype. I mean, whether you talk about Hinton making the statement that radiologists will be replaced in 5 years and might as well stop training for radiology. So what I'm trying to do is actually be a major proponent for machine learning. I think you're absolutely right. There have been major exponential changes. But I don't see any horizon where it's going to do some of the things that have been claimed, like replacing physicians or radiologists. I think it's going to work in concert. And that's really the point I'm making. So I'm super excited about the technology, super excited about what you guys have been doing. But having medical students come up to me saying they're thinking of dropping out of medical school, thinking about not going into particular specialties, that's really completely different from what I think you have in mind and what we have in mind also. But there are folks within your community and the AI community that are making those statements. And so having an education of what we do and what we have, and having Hinton and other folks educated as to what is really the level of complexity that we're doing, and even if we're progressing exponentially, I think there's a long way to go before we have what I'd consider general AI or a stronger AI. And I think we're still in the infancy there, even despite the exponential changes. So it's fantastic to have you here, and thanks for all the amazing stuff that you guys have done, and can't wait to see what happens in the next little bit. But that's really why, if I sound negative, it's really I want to counteract some of the hype that our colleagues are feeling the heat of.
So, yeah, that's fair.
Yeah, well, thanks.
That was an awesome presentation.
Thanks.
I'm also a radiologist myself.
Oh, wow.
Very nice to meet you. My question is, I haven't heard anyone addressing the potential labor market with the emerging technology.
Yeah.
I personally don't have any fear about this technology,
Good.
but like technology has been replacing certain tasks and
Sure.
and jobs, and
Yep.
you know, there are, you know, we have seen in the legal field, for example, a lot of young lawyers were trained and they couldn't find jobs out of school.
Yes.
Do we have any exit plans for people?
Yeah.
Alternative path?
Well, it's interesting. I mean, if you take a look at the Industrial Revolution in the early 1800s, this was exactly the concern that we had. And then wave 2 of the Industrial Revolution and 3. And so if this is wave 4, I think the same thing's going to happen. I think we're going to retrain and relearn. You know, medical schools are now teaching people how to use the tools, not just how to memorize and do rote memory. And what I think is going to happen is we're going to end up rethinking the types of jobs that we have. And I think we need to prepare for that. The other thing that I think is really important is that, you know, we train ourselves to have a really good understanding of how to best use the technologies. So I personally think that we're going to have more jobs, but we're going to have to be creative and flexible as we end up moving on. So it's a great question. If you look at The Economist in the June edition last year literally talked about what are we going to do when computers replace everybody? In other words, how are we going to have an economy, and how do we continue to pay people money when all the computers are doing all the work, we're not doing work anymore? And I think that's a little premature at this point, and I think, you know, maybe there will be a 5th revolution sometime in the future, but we've done really well with the first 4 revolutions as far as retooling and changing the labor force, and I'm really optimistic that that's going to happen with what's happening with AI as well. So it's a great question, and I'm glad you're not concerned about being replaced anytime soon.
I think part of the fear is that there is no any defined vision for us, that what really this new role is going to be.
Yes.
And I think the industry sometimes should think about that.
Yeah.
Maybe you will get more cooperation.
And I think, as our colleague essentially from DeepMind is saying, one of the challenges is the change is happening at an exponential rate. And so things are happening really quickly, unexpectedly, and maybe in an unaccustomed way quickly also. And so I think we need to educate folks, and forums like this are fantastic for being able to do that. So thanks for your comments. Really appreciate that. Maybe one last question.
Well, I was going to comment that it's ironic that the same computer community, Silicon Valley community that you're talking about, also is talking about immortality. And if you think about what that kind of aspiration really means,
right?
yes, even if computers were able to completely do everything today's radiologists can do, by that point we're going to have so much more knowledge and so much higher of an aspiration to live longer, to achieve more, to make our bodies function better. It's only reasonable that this bar will just keep getting raised higher. Don't you believe that?
Sure. No, I agree with that. I mean, one of the really interesting things about general AI is the potential to be able to build an AI software system that can write software that can further accelerate the rate of AI software being written. There are already papers that are out talking about software that's able to facilitate the rate of development for AI technology. And so, you have this Kurzweil singularity, essentially, where systems get smarter and smarter as time goes on. And you're absolutely right. More and more research is being done now in curing disease, not by just kind of a whack-a-mole method of let's try and cure cancer and then we'll try and cure cardiovascular disease, but actually thinking of aging as a disease. And there's a lot of work that's being done recently on looking at the potential to be able to try and attack aging in general, and that's a whole other topic. But I think the whole idea of AI accelerating to the point where software can facilitate the development of future AI may actually accelerate that exponential curve, and figuring out how do we all in healthcare take advantage of that, deal with that as time goes on, make it best for our patients and our own lives is really important. So that's a great last question to end on. Thanks a lot. Thank you all very much for attending. Really appreciate it.
And please pick up a schedule for the rest of the Philips Connected Health Forum. At 2 o'clock, we have Tom Zajac, the CEO of Philips Wellcentive, who's going to be talking about how population health can help your healthcare organization. So please come back at 2 o'clock. Thank you very much.